Okay, students, let's try to solve the same question from method 2. And you remember that in the last video, I told you that we have to find out acceleration in M3. So this acceleration A. Okay, so now this time we will make equation by trying free body diagram for every mass. Okay, so this is our rectangular coordinate system for M3. Okay, conventionally, the this is a positive y-axis, and if it is accelerating up, it means that for this the upward tension force must be, and I'm saying this is a tension T1 for example. Okay, and that must be M3g. So M3g is the weight of this mass that is less than the tension in this cord. So it means that it, like, what is a resultant force? So the resultant force for this must be equals to T1 minus M3g is equals to, we are writing Newton's second law equation for mass M3. That's why I will write M3a. Okay, now let's come towards the mass M1. Okay, because M1 is a mass that has a more weight. Once again, our rectangular coordinate system is same like this. Okay, but you know that its weight must be more than the weight of the third M3 mass. Okay, because it is accelerating down, so the tension in this string is, let's say, T2, because this is the second chord. So what is the equation of for this mass according to Newton's second law? So the resultant, you can write m1g minus T2 is equals to m1a. Why m1? Because we are writing second law equation for mass m1. Okay, so this is an equation according to the Newton's second law. Now let's talk about the mass m2. Okay, so don't you think the mass m2 is also accelerating in this direction? Although it's a negative acceleration because it's accelerating towards negative x direction, but look at the forces which are applied on the m2 horizontally. So the one force is this one. Dear students, don't forget that this is a frictional force, so that's why it should be mu times the normal force exerted on m2. That should be m2g, because normal force m2g is equal to the weight. Why weight? Because this mass m2 is accelerating on a horizontal surface. All right, that's why the m2g, the normal force, is equals to m2g. All right, so when we will make equation, and what are the other forces? This force, you remember, it's a tension T1, and this force, tension T2. So students, for more clarity, I have drawn this diagram again for the mass m2, you, just to show you that this is a force of tension which we are saying T1, and this is a force, a frictional force exerted on m2 by the surface of table, that is equals to mu times the normal force, which is equal to the weight. Normal force is equal to the weight, whereas this is the direction of the tension. All right, so which we are saying the tension T1. So from this diagram, I'm not showing, I have not shown you the vertical forces, so you can make the equation from this. So the larger force minus the sum of smaller forces, okay, must be equals to, this is T2, is equals to m2a. So I hope you understand this. In this solution, while you see that there are three unknowns. What are those unknowns? The tension force, acceleration, and the tension T1 in the chord 1. All right, so you need basically three equations if you want to find out acceleration. So you need three equations, and then you have to solve them simultaneously. I'm going to write all of these equations on one side. So students, I have written three equations. Now our goal is to eliminate the two unknowns. The one is a tension T2 and other one is a T1. Then we will be able to find out acceleration A. And how can you, if you just give less than 1 minute, you can easily guess about it. Why not I should put the value of the tension T2 here and the value of the tension T1 here, then we will finally ultimately get an algebraic equation in which we will have just one unknown. So let's try this method. So what I'm saying, if we put the value of tension T2 here, and that should be equals to, first of all, you must write equation of the tension T2. Okay, means that take it on the other side, make it subject, and minus m1a is equals to tension T2. Now we can substitute the value of T2 here. Okay, so in the next step, I'm going to exactly write this thing at the place of tension T2 in our third equation. So follow this, m1g minus m1a. Okay, then minus inside mu m2g, or you can open the bracket, in fact, mu m2g minus t1 is equals to m2a. I hope you understand this equation. Now, dear students, this is the time when you have to put the value of or equation of tension T1 here. So students, and that is m1g minus m1a, the equation as it is, minus inside the bracket the value of the tension T1, the equation of the tension T1 is equals to m3a plus m3g. I know it is becoming complicated, but I am just showing you another method to solve this. It is interesting. Okay, now students, you see we have got a one equation in which we have just one unknown acceleration. So now our next step is to gather all of the terms which share the acceleration a variable. Okay, so that's a simple m1g, open the bracket, minus mu m2g. Okay, minus, when you will open the bracket, this negative sign will make this m3g negative, so m3g. Okay, what about the terms with acceleration? So now minus m1a minus m3a is equals to m2a. Now you know what should we do next. We should take this term on the other side, as well as we should take this term on the other side, and this will become, on the other side, both of these terms will become positive. All right, so now you can take the acceleration out of every term, you can separate it, so it will become the total mass on the right hand side of the equation, whereas you can take g out of every term here because that is common. So inside we have m1 minus mu m2 minus m3. Okay, so I have made another video in which I have solved it by some other methods, so you can also watch that video. And m1 minus mu m2 minus m3 divided by the total mass. Okay students, so you see that we have solved this, and finally it is our option D that is the right answer. I hope you understand this solution, and this was another method on which I have made separate video.